Hi, my name is Stewart Lynch, and in this video I'm going to cover one of the most confusing topics encountered by new Swift developers, and it's optionals. Feel free to use the chapter links in the description below, where you'll be able to jump directly to the section you want to cover. If you're really puzzled, I suggest you work your way through the entire video. We'll be covering what optionals are, forced unwrapping, optional binding with if-let, optional try with throwing functions, optional binding with guard-let, the nil coalescing operator, and optional chaining. If this is something you want to learn, then keep watching. For this video, we'll be using an Xcode playground containing many sections. You can download the starter playground from the link in the description below. Throughout this video, we'll be entering our code within a code block closure. I've taken a page out of some Ray Winderleit tutorials and have created a public function in the sources folder for each of these pages that'll allow you to have our code for each section self-contained within a closure so that when we view our print statements in the console, it'll be clear what section we're referring to. It also allows me to reuse the same variables and function names in each closure. Let's start with the very basics in our playground page. What are optionals? An optional represents two possibilities. Either there is a value, and by unwrapping the optional you can access that value, or there isn't a value at all. Another way of saying this is that optional values can either be nil or have a value. Here's that helper function in action now. All code will be entered between the braces. Now we can designate a variable as optional by typing a question mark right after the type annotation. So let's start by creating an optional string variable called dogname and assign it the value Rupert. Then we'll print out the sentence using the string interpolation, my dog name is dogname. For the time being, let's just ignore this warning. This will all come clear when we start talking about unwrapping optionals. When we run this in the playground, we get a nicely formatted output. But instead of printing my dog's name is Rupert, we get my dog's name is optional Rupert. And I can assure you my dog is not optional. See? However, what if it were? What if my dog, heaven forbid, dies? And in that case, you might think you can just change the name to an empty string. This kind of gives me what I want, but really, I could have been lazy and not given my dog a name. After all, it is optional, isn't it? The dog is still alive, he just doesn't have a name. Well, that's not really what optionals are all about. If my dog dies, he doesn't exist, with or without a name. With optionals, if it doesn't exist, we assign it nil. Now when I print it out, the optional wrapping of our name is removed and we get nil printed out. This then, in a nutshell, is the whole reason behind optionals in Swift. If our dog has died, we need to know this and deal with it accordingly. If the dog is alive, then we must have a name which can, by the way, still be empty string. We can unwrap that package, so to speak, to remove the optional wrapper. One of the first things that beginners do when getting warnings you see in the first example is to do what is called forced unwrapping. Let's just copy the code from our first example and place it in the body of our second example. But this time, when we print out dog name, place an exclamation mark after dog name for the first time we assign the value to dog name here. You see that the warning disappears, and when we run our playground, the result is showing that the name has been unwrapped, and our output is now usable in our code. Perfect. So, for consistency's sake, let's also do that for our second dog name. That removes our warning. But when we run our code, we get a crash and a fatal error, unexpectedly found nil while unwrapping an optional value. You see, Swift is known as a type-safe language. It implements type safety, which basically means that you can't use a variable inappropriately for the terms of its type. This means that you'll not be allowed to multiply two strings because that wouldn't make sense. In the same way, it also means that if a value doesn't exist, then you can't use it at all. With optionals, you can't unwrap it if there's nothing to unwrap, and that's why our playground crashed. You should almost never forcibly unwrap an optional. There are just too many ways that things can go wrong in your code, and that will come back to bite you. You need to first check to see if it's nil, and then, and only then, forcibly unwrap. So to fix our code, we can do that check and only print if the dog name is not nil. Now you may think that this is pretty dumb because you can see the dog name is nil. So why would I even attempt to force unwrap it? Well, the fact of the matter is you don't always know if you're going to get a value or nil. This happens all the time when you're dealing with APIs. And just to enforce this, you'll see that in my public functions file, I have a simple function that may or may not return a random integer between 1 and 10. It doesn't matter if you understand how this function works any more than you need to know how an API that you are working with sends you its response. All you need to know is that you may or may not get an integer from this function. It's optional. Let's test this out. Let number equals random optional int. Now if you option click on the constant number, you can see that the number is indeed declared as an optional int. So when we print it out using string interpolation like this, we get that warning. If we run it a few times, sometimes we get the unwrapped optional printed, and sometimes we get nil. The trouble is we have no idea what we're going to get. Yet, in order to work with that value, or the result from our API, we need to unwrap it or deal with the nil value. If I force unwrap it, it's a crapshoot whether or not my app, or my playground, will crash. Well, we can deal with that as above by first checking if it's nil before unwrapping. So as above, we check if number is not equal to nil, and then use the else part to print out an appropriate statement if it is. Now when we run, we no longer get a crash. Now sometimes you want to do as I've done above by offering an alternate statement, or as we did with the dog name, just ignore it. For the rest of this video, we're going to look at a variety of different ways of dealing with optionals without actually force unwrapping at all. An alternative to force unwrapping an optional is to use optional binding. You use optional binding to find out whether an optional contains a value, and if so, to make that value available as a temporary constant or variable. Optional binding can be used with if and while statements to check for a value inside an optional, and to extract that value into a constant or variable as part of a single action. To bind an optional to a temporary constant or variable, we use if-let, and we typically use the same name for the temporary constant as the optional one. For example, let's get another optional random integer. We can then say if-let number equals number, and what we'll do is only assign an unwrapped version of our optional to our temporary version if our optional is not nil. If you option click on the first number, we see that it's an optional. If you do that same thing on the second, we see that it's no longer an optional. The temporary one has been unwrapped. So there's no need to force unwrap it in the print statement after it's been defined. If we run this several times, we see that sometimes we get a number printed and sometimes we don't. On my first attempt, I get 5, 1 on the second, but on the third attempt, there's no response. Now we can shorten the above code a little by simply checking against the function instead of first assigning the return value to a constant. And we can also add an else statement to convey when no number is generated. Now this time on our first run we must have received an optional because our else statement is printed. On the second run we get 3, and on the third a 4. Let's segue just a little now and consider a throwing function. If we check out the public functions for this page, you'll see that I've added an error enum and a new function called spin wheel. If you're not clear on throwing functions, and do, try, catch blocks, I suggest that you take some time to watch my video on that topic. I'll leave a link to it in the description below. What this spin wheel function does is generate a random integer between -5 and +5 inclusively. If the number is a negative, it throws or generates an error of type myError.NegativeNumber. If it generates a 0, a different error of .0 is thrown or generated. Otherwise, it returns an integer. And notice that this integer is not an optional. So to generate a number, we need to use a do, try, catch block here to catch if an error is thrown. We start with do, then let number equals try spin wheel, and then we can print it out. Now again, that number is not optional, so no unwrapping is necessary. If there is an error, we catch it and print out the error. The first run generates a negative number error, and that's caught and printed out. The second run generates a positive integer 1, so no error, and our print statement is used. Now if I run this enough times now, eventually I'll get a 0 error. Finally. Now I suppose you're wondering why I introduced this topic here. It seems out of place. Where's the optional? Well, if you could care less about what the error is, you can use the optional version of try. Try ? And forget the do catch block altogether. Let number equals try ? Spin wheel. If you option click on number, we see that it generates an optional integer. And we know how to deal with that. So we can change our function to use if let. Now you see it's no longer optional, and we can print out our number or else generate an alternate statement. Running this, we get 3 on our first run, then no number on the second run. Now before I move on from if let, consider the following scenario. Look at this function. We only want to display information if we have non-nil entries for all 3 arguments when we call this function. So when we call the function, we want to return a string either showing an error or the complete submission. Now we can do this by checking all 3 in one single statement using if-lets. And then we can print out the information if all 3 of these pass. Now I like to use Swift's multi-line print capability, so I'll surround my return text with triple quotes and format it to give me my output. Now if any one of those if-lets failed, we'll have to use an else statement and return a string missing information. To test this out, we can create a submission using values for all 3 arguments. And then we can print the returned value. In this case, since all 3 have non-nil values, we get our full submission. If any one of our 3 arguments is optional, we get our error message. Now we may wish to be more prescriptive to our users, however, and let them know what is missing. So we can start off with some nested if-lets here, checking one at a time. If let name equals name, and nest if let city equals city, and finally if let prob state equals prob state. And if we made it this far, we must have all 3 so we can return our string. However, since we must return a string for this function, we need some else statements here. Now I'm going to simplify things a bit here and return a missing string as soon as we encounter something missing. I won't go into trying to do compound cases of missing items. So working from the inside out, our first else statement will be return missing province state. Up one level, we must be missing the city, so return missing city. And finally, up one more level, we're missing the name, so return missing name. We can try a number of different types of submissions and see that a response reflects what's missing. Now this is a bit of a pyramid of doom here, so it's time for another approach. Swift's guard keyword lets us check if an optional exists and exit the current scope if it doesn't, which makes it perfect for early returns and methods. So let's revisit some of the examples from our last page. Instead of using if-let to bind our optional random integer to a number constant, we can use the guard statement, and it goes like this. Guard let number equals random int. Now if we stop typing, we get an error that says expected else after guard condition. Anytime you use a guard keyword, you must have an else statement. So we do it like this. Now this creates another error. Guard body must not fall through. Consider using a return or throw to exit the scope. So you see that we must either exit our scope with a return or a throw. Let's stick with return. What we're doing is checking for optionals up front in our code. And if the value is nil, we have a code block to deal with that, and then we must return and go no further. It means no nested if-else loops. If I option click on the number, we see that it is now not optional. So I can print it out without having to unwrap it. If we really need to print out something indicating that we found nil, we have to do this before our return. Testing, I get 8 on the first run, and the second run, no number was generated. And this is almost the inverse process over the if-let. The order of our print statements are reversed, and there is no else statements because we must exit the guard with a return so it can go no further. Let's see then how that might help us with our pyramid of doom example. We can use guard and do a pre-check and early return up front with a guard check on each of the optionals. If it is nil, we can return an appropriate string. Guard let name equals name, else return missing name. Guard let city equals city, else return missing city. And guard let prov state equals prov state, else will return missing province state. And since we've now checked all possibilities, we know that all of our temporary constants are unwrapped, and we can use them in our return string. Compare this code here now to what we had in the last example with nested if-lets. I hope you see that there's an improvement. I'll just copy these 2 lines of code, and we'll do the same test. Eventually, when our submission no longer has nil values, we get our full submission printed out. So when would you use if-let or guard? Well, the difference is a bit subtle, but it is there. Guard should be used when certain values are expected to be present for the function to execute as intended. In other words, use guard when you want to exit quickly out of a function and not carry on any further. I think you'll see that in our submission case here, guard is a much better choice and much easier to follow than the if-let case we saw in the last playground. Optionals are a powerful source of safety in Swift, but can also be annoying if you find them littered throughout your code. Swift's nil coalescing operator helps you solve that problem by either unwrapping an optional if it has a value, or providing a default if the optional is empty. For example, we can return to our first random integer example once more. let number equals random optional int. Print the number is number. We get that warning that we saw in our first playground that I said to ignore. Now, if we tap on the warning, one of our options is to provide a default value to avoid this warning. And when we tap on it, we get 2 question marks following our number in the print statement, suggesting that we provide a default value. This default value will only be assigned if our random optional int provided a nil value. And since we are always generating a positive integer, let's assign -1 if it is nil. If we run this a couple of times, we see that we never get a crash, and we'll get a positive integer from 1 to 10, or we'll get -1 whenever it generated a nil value. Now, instead of doing this nil coalescing in our print statement, we can do it upon assignment. So let's repeat this code here, but we'll take out the nil coalescing in our print statement, and our warning returns. If we option click on the number, we see that it is indeed an optional. All we have to do to turn this into a non-optional is to apply the default values to the return value of our function. Option clicking our number shows it is now non-optional, so no error either. Now, the only other thing I want to mention about the nil coalescing operator that has confused me in the past is when you're dealing with strings. If you refer to the public functions for this playground, you see that I've added another function that will either return one of these 3 words, or it will return nil. Again, there's no need to understand how this function works. Just know that you'll receive an optional string as a return value, or nil. So let's use this. Let word equals random word. Print my word is word using string interpolation. Of course, because the function returns an optional, I get a warning. So let me try to fix this with the suggested fix as before. Just remember that the default value must be of the same type as the return value. So we need to enter a string here, and that string must be in quotes. What bothers me about this is that we have quotes within quotes, and for me that's always been a sticking point, so I just wanted to bring this to your attention. As I test this, we'll either get a random word or the statement, no word returned. Again, if we copy and paste this code into our second instance here, we can remove the nil coalescing from the print statement and add it to the initialization of our constant. And I think that's clear. In fact, I believe that this is the basis of MVVM, or Model, View, View Model. We should be keeping our code away from the presentation layer, or the print statement. If you've watched any of my technique videos, you'll know that I'm a big fan of MVVM. Optional chaining in Swift is the process in which we can query or call the methods, properties, or subscripts of an optional object that might be nil. Consider these 2 classes. A parent has a name and can optionally have a child. And since the child is optional, there's no need to have it initialized. If the child exists, it must have a name, and the name is not optional. In our first example, let's create a parent who we shall call father with a name of Stewart. And by default, the child is optional, and since it's not initialized, it must be nil. If we wish to access the name of the child of a parent, we must be careful. For example, let's try this. var child name equals father.child.name. We get an error that the value of the optional type child must be unwrapped to refer to a member name of the wrapped base type child. This means that we can't get the name of the child if it doesn't exist. Xcode is smart enough to know this, and more often than not, it will put a question mark after child to denote that it's optional. If not, you can tap and fix and select the option to chain the optional using question mark to access the member name only for non-nil based values. I warn you against using the forced unwrapping, so we'll use the optional question mark and note that it adds it after the property that is the optional. If you option click on child name, you'll see that it is defined as an optional, even though if we had a child, the name itself is not optional. This is optional chaining. Let's use the nil coalescing operator to assign a value of no child if the value is nil. So this now turns child name into a non-optional type. If we print this out, we get the expected result. So let's assign a name to the father's child. Father.child.name equals Aiden. And we'll reassign this new value to our child name variable. We'll print it out again. Did you get what you expected? This is a common mistake that new developers often make. The problem is that we've not yet created a child. You might assume that trying to access a non-existent entry would have raised an error, but it doesn't because we're optional chaining. It just produces nil, and we had provided an alternative. If we want to assign a name, we have to have a child. So let's comment out these lines that don't give us what we expect. Now let's create a child who we will call son with the name Aiden, and we'll assign that son to the father's child property. Then, as before, let child name be equal to father.child.name using the nil coalescing operator to help us unwrap it if I forgot to add a child. Now we can print out the child name. Let's go back and create a new class called pet that has an optional name property. Yes, some people don't name their pets. Now we'll add an optional pet to the child. Now nothing breaks in our code because pet is optional, and when we created our child, there is no need to initialize it. Now as time goes on, our son gets a pet. So let's create a pet and assign it to our son. Now if we want to assign a pet name to the pet, we can do it 3 different ways. We can assign it to the pet directly, like pet.name equals Rupert. But we could also start assigning it starting from the son object. But this time we'll need to use optional chaining because for son, pet is optional. Similarly, if we wanted to start from the father to assign the name, then we have 2 optionals, both child and pet in the chain. If we print out our pet name, we see that it is still optional. So we can use the nil coalescing operator to handle that final property. To finish this up then, let's look at one more example of optional chaining. I'm going to create a parent called Mother with the name of Catherine, and a child called Daughter with the name of Allie, and then assign the daughter to the child property of Mother. Now I only want to carry on with creating a pet if Mother has a child, and this is the ideal situation to use guard. I can use guard let child equals mother dot child, else I can print out no child and return. This gives us a warning because we're trying to bind an optional value to a constant child, and I'm not actually going to use child in my code. When this is the case, we can replace our constant with an underscore. And now that I know that this mother must have a child, I can create a pet and give it a name. And now I can assign this pet to the child of the mother, and since we have already confirmed that the mother has a child, we can safely, in this case, unwrap the child in the chain. And finally, if we want to print out the names of the child and the pet, we can access daughter.name, which is not optional, and pet.name, which is optional. The name property of pet is optional, so we'll either have to force unwrap the name or provide a default value. And I know for a fact in this case that there is a name, so I'm going to take a chance and force unwrap it. Probably not the best idea. In any case, it is what it is. I hope now then that you have a better understanding of optionals and how you can unwrap them if they provide a nil value. I have lots of other videos available and in the queue as well, so please check out the rest of my channel. You can also visit my website to see the apps that I have available on the App Store, and visit my GitHub page to see what I have available as public repositories. If you like what you've seen, give it a thumbs up and subscribe to my channel. And ring the bell to get notified when I post new videos. I'm most active on Twitter, so please follow me there as well to find out what else I'm up to. Thanks for watching.